honored experts. I am honored to have the chance to make a speech. The topic on my paper is Conflict Coordination Method of Heterogeneous Educational Resource Sharing based on blockchain. The first part, I will introduce the background of this research. The second part, introduce this method. The third part, introduce conflict coordination experiment. Finally, a simple conclusion is given. Let's move on the first part of this topic. Background of this research. First, the traditional teaching mode and methods are no longer applicable to current social requirements. Second, sharing educational resources can alleviate the shortage of high-quality education resources, improve the overall quality and level of education in colleges and universities. Third, sharing educational resources make colleges and universities explore new development. What problems need to be solved? There are often conflicts in the sharing of heterogeneous educational resources. What have we done? Blockchain is applied to the research of heterogeneous educational resources, sharing conflict coordination, and a method of heterogeneous educational resource sharing conflict coordination based on blockchain is proposed. Let's move on the second part of this topic. Blockchain-based heterogeneous education resource sharing conflict coordination method. First, I will introduce construction of distributed mobile dynamic cooperation network. The distributed mobile agent dynamic cooperation network is constructed based on blockchain to provide a new distributed computing model. In the dynamic corporate network model of distributed mobile agents, the agents involved in computing can be divided into two types: mobile agents and service agents. In the model, each mobile agent represents a mobile user. The mobile agent is in wireless communication network and the intelligent mobile terminal. With the support, it will have the ability to perceive changes in environment and can make independent decisions and communication with each other. The service agent is static. It only publishes the service plan, accepts the service reservation, and the scheduled change. Left circle design of mobile agent. The left circle of mobile agent is divided into the following 5 states. Initial state, cooperative state, locked state, complacency, offline state. Initial state, when the mobile agent enters the wireless network environment and is created. It enters the initial state. The mobile agent in the initial state can either choose to develop a personal action plan or leave the mobile environment. If a mobile agent has formulated a personal action plan, its state will automatically migrate to cooperative state. If it chooses to leave the mobile environment, its state will automatically migrate to offline state. Corporate state. A mobile user in a cooperative state indicates that this user hopes to establish a dynamic cooperation network with other mobile users to improve their action plan according to collaboration strategy. When a mobile user indicates a creation or has joined a dynamic cooperation network, its state will automatically migrate to the locked state. If it does not want to cooperate with other mobile users, it can change its state to complacency or offline state. Locked state. If a mobile user is in a locked state, it indicates that it is cooperation with other mobile users in a dynamic cooperative network until it exists the current cooperation network. It cannot join other dynamic cooperation networks when it exists the current cooperation network. Its state will automatically shift to a cooperative state. Complacency. Complacency indicates that current mobile users do not expect to cooperate with other users at the moment. Mobile users in the complacency will refuse to join our dynamic cooperation network unless they remigrate their state to cooperative state. Offline state indicates that the user has left the mobile environment and the life cycle has ended. Design of interaction mode between mobile agents. In its life cycle, a mobile agent needs to interact with the external environment, which include not only the interaction between mobile agents, but also interaction between mobile agents and service agents. Listed by chapter Network System Processing Design, in which they are discussed in detail. Message pattern design. The message mode between mobile agents is designed, that is, the message transmission format is name ID, state, action. The message passing format between a service provider and a mobile agent is name ID, action. The name ID represents the ID of mobile agent or service provider. The state represents a certain state of mobile agent. An action represents the actions that the agent or service provider in a certain state can perform. Network System Processing Design. Design the process of distributed mobile dynamic cooperation network, including the system process of create behavior, invite and accept, reject behavior, update and complete behavior, query and response behavior. System flow chart of create behavior. The create behavior is sent by mobile users. Because they share a certain variable, the mobile users in cooperative state send a message of create dynamic cooperation network to the service provider, requesting to create the network for cooperation. Flowchart of invite and accept reject behavior system. When a mobile user is in cooperative state, Because a certain variable is shared, the relevant mobile user of this variable can be invited to join created collaboration network. After waiting, the relevant mobile user can choose to accept or reject the invitation. If the invitation is accepted, the relevant mobile user state is set locked. Otherwise, it is still cooperative state. Flowchart of update behavior system. The mobile user in the locked state sends the update message of the shared variable to the relevant mobile users. Participating in the collaboration network platform that affects the shared variable. Flowchart of complete behavior system. After the relevant mobile users accept the update, the service provider modifies the relevant information and will complete the information is sent to mobile users, and after mobile users' information is updated, the locked state is set to cooperative state. Flowchart of query and response behavior system. When mobile users are in a cooperative system state, they can query the service provider for information about mobile users that affect a certain shared variable or other service reservations, and the service provider will send a response message to the mobile users regarding relevant information. Let's move on to the third part of this topic. Conflict coordination experiment. Experimental design. In the experiment, 5 universities were selected as samples to obtain their heterogeneous educational resource sharing and conflicts. These colleges are all in densely polluted area with certain shared participants, and the college are of different types. In the experiment, the cooperation depth of the dynamic cooperation network is set to 3, and the maximum number of subnodes allowed under each node is 3. The network topology of each university is shown in this figure. To make experimental results comparable, 2 methods were used. According to the comparative experimental data, method based on blockchain is higher than methods based on context awareness. Conclusion. Research on the method of sharing conflicts between heterogeneous educational results can promote the improvement of high-quality educational results. Sharing methods in my country's universities and further promote the development of higher education. In this context, a blockchain-based method for coordination heterogeneous education resource sharing conflicts is proposed. The experimental results showing that this method has improved the degree of conflict resolution, which is of great help to the improvement of the degree of heterogeneous educational resource sharing. Thanks for your listening.